Thanks everyone. So my name is Ben, I'm from the Raspberry Pi Foundation. I work there as Community Manager. I write for opensource.com, and you've got my links to GitHub and Twitter, and my email address is there. So the main reason I sort of put this project together was because of this. So pip install numpy on a Raspberry Pi takes a long time. So Python wheels, as we all know, are built distributions that can be uploaded to PyPI. I'm going to be pronouncing it PyPI, I hope that doesn't bother anyone. Alongside source distributions. So source distributions is source code for a Python module hosted on the Python package index. You can also provide built distributions, wheels, which are pre-compiled, pre-built versions of those packages, which mean when you install them, you don't have to do the building yourself. So this saves users build time and other build problems like having certain dependencies installed, and they're a very effective way of distributing packages. However, wheels are architecture specific, so if you create a wheel on a Windows 32-bit machine, it will only work on other Windows 32-bit machines. So there's Windows 32, Windows 64, Mac, and there's a recent, relatively recent addition called Many Linux, which is a standard for multiple distributions of Linux, so wheels that support many distributions of Linux. But unfortunately, Raspberry Pi is not covered by this Many Linux standard, as it's the ARM architecture. So if we look at ARM wheels, so if you actually build a wheel on a Raspberry Pi, you get an ARM wheel, but it's an ARM version specific wheel. So technically, in terms of the hardware, a Pi 3, a Raspberry Pi 3 is ARM v8 hardware. Pi 2 is ARM v7, and Pi 1 and Pi 0 are ARM v6. But actually, wheels built on a Pi 2 or 3 are tagged with ARM v7L, and wheels built on a Pi 1 or 0 are tagged to ARM v6L. But they're actually ARM v6 instruction code underneath, and they're all actually the same. If you build a wheel on a Pi 2 or 3 and the same wheel on a 1 or a 0, you essentially have the same file, just with the tag named differently in the file name. So therefore, if you build a wheel on a Pi 3, it will be a lot faster to build, but renaming it to ARM v6L will make it work on a Pi 1. So what happens when you type pip install and a package like numpy? What it does is it goes to the Python package index, looks for browsers for your package you've asked for. First of all, looks for a wheel in the given architecture that you've requested, that you're on. And if it finds a wheel match, then you download the wheel and you install it, and it's easy as that. The fallback, if there's no wheel provided in your architecture, is to build it from source, so you have to sit there and do that. And if they don't provide a source distribution at this point, then the install will fail. So imagine you type this in, you send your request off to PyPI, and it says, well, what kind of x86 or x64 are you? And this is the page for numpy. I have them all. So as you can see here, you've got a load of CPython 2.7, 3.4, 3.5, 3.6, and then for each of those you've got sort of, this ridiculously long one is the Mac one, and then you've got Many Linux for 32-bit, 64-bit, and Windows 32 with AMD 64, and you've got all the different architectures for each Python version they support. And this is just one version of numpy, so every single release there's a whole batch of these they have to produce and upload. And when I started this project, you couldn't actually upload an ARM wheel. If you actually built one yourself and you wanted to upload one, it wasn't in the list of supported architectures, so it didn't allow those to be uploaded. So what kind of x86 are you? I have them all. Sorry, I'm having to use this keyboard. Let me get back to where it was. Actually, I'm Linux ARM v7L. I've never heard of it. Here's the source. Build it yourself. So, trying to pip install numpy on a Pi 3 takes 20 minutes. So you've got to quad-core 1.2 GHz processor, but on a Pi 1 it takes about 2.5 hours. So every time somebody types pip install numpy, this is the kind of install time it takes. So having a wheel would be really beneficial. So at this point, because PyPI didn't support uploading ARM wheels, I thought, well, fine, I'll build my own package repository. So I started the project, that's how it came about. So obviously the name I came up with was piwheels, and I thought, well, maybe I can build wheels of all the packages on PyPI and host my own repository. If you on a Raspberry Pi you type pip wheel numpy, that works. You get a file that you can distribute, and other people can install from that file. And that's a super fast install. And I looked into it and thought, well, can I actually host my own PyPI repository, or is that not something that works? And I looked into it, and yes, and they provide documentation on how you do that, but the bare minimum, like an Apache directory listing with the directories of the module names will do the trick, that will work. So my proof of concept, piwheels v1, was just a Pi 3 in my living room, and I iterated through the list of packages. There are 106,000 at the time, and I just built the latest version of every one. And logged the output into a Postgres database, so I could keep track on which ones I built, whether they built successfully or failed, and if they failed, then why, so I could look into it later. And I was hosting an Apache web server on the Pi, which was the package repository. And so that took 10 days to complete the build, so 10 days solid, 106,000 packages, 76% of them built successfully, and this was just live on a subdomain on my website. And pip install numpy from that server, using the iflag, worked, and it would take 6 seconds to install numpy. So I thought, well, this is definitely worth doing. This is, the proof of concept is that it works, and this is going to be useful. So I kind of did a second version. I thought, well, rather than just having the latest version, I kind of need to have every version, so I can support people building old versions of old releases of packages. And I want to be able to keep up with new releases as they come out. So I'll sort of do the backlog initially and then be able to keep up. Still want to host a package repository like I did before. And I wanted to kind of make this a nicer open source project so other people could contribute and that kind of thing. So planning this, by this point there are now 113,000 packages on PyPI, but now I'm building every single version of them. So I looked into that, and there's about 750,000 package version releases out there. And so at the previous rate, this would take about 70 days on one Pi to complete that whole build. But I thought, well, maybe I can scale this up. And Mythic Beasts are the hosting company we use at Raspberry Pi. They host our website and help us out with a lot of other stuff. They actually provide Raspberry Pi 3 servers in the data center. So you can hire out a single Raspberry Pi, and you get the whole thing. It's not virtualized or emulated or anything. It's a real Raspberry Pi 3 piece of hardware that you can just spin up and get access to and use for whatever you want. So I thought, well, that's kind of a nice way of actually doing it, because I want to do this on real Raspberry Pi hardware, and rather than running it out of my living room, I'd rather just be able to spin one up like a server. So yeah, they provide this service, and so Pete is one of the directors of Mythic Beasts, so he's a friend of mine, and if you know anything about Mythic Beasts, is that you can walk into a pub in Cambridge and you'll likely bump into one of them sitting there working at a laptop. So I went along to the Haymakers and found Pete and had a chat with him. I told him all about the project, and he thought, well, this is great for the Pi Cloud. This would be a really good sort of test candidate, and yeah, and he let me have access to them and said, just fire them up, and you won't be charged for them. So I started off with building my V2. So I've been working on the source code of the project on my laptop for a little while, and I deployed it to one of the cloud Pis. So it was just one Pi to start, and I left it running for a couple of weeks. I went away to Italy for EuroPython, and sort of left it running and just kind of checked in on it. And I actually noticed it was running slower than it was before, because the Mythic Pis they don't have an SD card, they netboot, so they run on an NFS server. And so looking at the time it was actually taking to get through builds, my new estimate was that it was going to take about 100 days of a single Pi's time. I gave a lightning talk at EuroPython about the project, so I want to sort of put it out there and get some feedback. And a couple of people came up to me afterwards and saying, well, why don't you just cross-compile? That will solve all your problems. And I kind of thought, well, it's not just about speed, because I think this is only something I have to really do once, and then I just have to keep up. And I can easily scale up the pies. But really, I kind of don't want to get into the idea of cross-compiling, because I want them to be reliably. I want to reliably know that I built this on Raspberry Pi hardware and that they will be compatible. I'm very familiar with the Pi platform, and it's very easy for me to use. I can easily scale these up, and of course, eating my own dog food, I want to know that the Raspberry Pi is good enough to sort of do a project like this. So I went over to the Devonshire Arms and I had a chat with Pete. And I said, please, sir, can I have some more? And he said, oh, this sounds fine, yep, just fire them up if you want to. So I fired up 20 in the end. But just looking at how I got started with that, so I provisioned the second one, but this one didn't have the web server and it didn't have the database on it. Connected to the database on the first Pi. It rsynced the files over to the first Pi and put those in the web directory. And I sort of got it running and it was up and building. Provisioned the third Pi. Then I installed something called Terminator, which allows you to manage multiple SSH sessions in one go. And did Pis 4 and 5, and I thought, oh, this is great, it's kind of quick to just provision one up and install the bits I need and have them have them connect to the first Pi for the database and ask which package it should build, and they were all sitting there building. So yeah, later on my sort of Terminator thing started to look like this as I added more Pis. But unfortunately it didn't scale. The output on 3 Pis at this point was about the same as I was getting on 1 Pi, because each of them doing the query saying what should I build next was just being piled up, and they were all getting sort of this the backlog of all these queries. So the database was just getting hammered, and it didn't really just scale up like magic. But I was talking to my friend Dave Jones about it. Fortunately, I know him, and he's a self-professed SQL know-it-all. It's in his Twitter bio. He's the author of the PyCamera library for Raspberry Pi, and the co-author of GPI 0, the library that I maintain. And he's done a lot of work on that with me. We've worked on a lot of this sort of stuff together, so we're quite comfortable working with each other. And I was chatting to him about it the whole time, and he threw in a pull request with some query optimizations, and he introduced a queuing system with 0MQ, which allowed it to, rather than do that query, that complex query every time to do the join and work out what it needed to build next. It just allowed them to push jobs onto a queue, and they would be distributed to the builder Pis. So now the original Pi that's running the database and the web server is now the master, and it's not doing building itself because the CPU load on that Pi was getting quite high. So it's like, well, that one doesn't need to do building as well. That can just be for the others. So all the other ones are now builders using the master's database and rsyncing the files onto the master. And it works, and I'm firing them up. I got all the way up to 20 Raspberry Pis, and so 19 builders and 1 master. And then it was working happily. So I was getting through about 3,000 packages an hour and 72,000 a day, which is about 10% of the whole lot, which meant that I could kind of see this being done in no time. It was going to take about 10 days. So they're now also logging which Pi built the package, so I can kind of keep an eye on which ones are building, if there's any issues, if any of them have been held up. And I dropped rsync in favor of SSHFS, which we later dropped for something else, but yeah, that seems to be going well. So at this point, you kind of notice that some of the Pis were dropping off, and you think, oh, number 7 hasn't built anything for the last couple of hours, what's going on? You'd go in and SSH into that one and have a look, and it would just be sitting there saying, oh, what's your github.com username? Because somebody's done it, out to bash, git clone this other repo to bring in this dependency that's not packaged, and I can't use the normal tooling for it. So they've done all this stupid thing like that. I saw random files created in my home directory, random stuff appended to my bash RC. This is running, 100,000 people's code that I found on the internet. So kind of, you can't.
Bad things happen.
Yeah, these things happen. Some people will git clone their setup.py, and lots of people do stuff in their setup.py because they think you're installing it. because you're running that file. But I'm not installing it, I'm just building a wheel out of it. So they would assume that you have the dependencies that, that the user needs, because you're running setup.py. And so they do stuff like, from my package file, import dunder version to get the version numbers in their setup.py. And inherently in importing from that file, they run the file, and that has an import numpy because their library needs it. And I didn't have numpy because I'm using a very basic light image, and it would fail at that point because I didn't have the dependency that I didn't actually need to be able to build it. But because it was in there, it would just throw an error and give up and move on. But looking at the results, so we got through 113,000 packages, 752,000 releases, of which we managed to build 570,000, so over 500,000 successfully built packages. The cumulative build time for this was over 150 days, because I actually realised that the queuing system was allowing duplicates to take place. So I actually was watching the control thing at one point, and I got to 100%, and I celebrated, and then it got to 101%, and I thought, what? And so it kept going up. I was like, what, Dave, what's going on? He's like, oh yeah, it might be doing duplicates. It's like, all right, there's another couple of days left then. But in real time, that was 16 days of just one Pi building when I went to EuroPython. And then once we sorted out the scaling issue, just another 10 days, and we got through the whole of the rest of it. It used up about 250 gig of disk space, and we were able to look at the reasons for failure. So one of the major reasons for failure was no release, which means in our database has picked up that a release exists, so like numpy 1.0.7 or something, but they might have registered the release but never uploaded any files to it, whether it's source distribution or wheels or whatever. And so a big chunk of that we didn't even need to try and build because there's nothing to build. So they're definitely not failures. So we can actually drop a load of those and say we don't care about those. You've got a bunch of things like import errors, so that just means missing dependencies. Syntax errors could be, this is a Python 2 only project and there's a print statement, something like that, or actually just errors in people's code that they've released. So yeah, we were able to discount the no-release versions and install did some analysis on this and looked at the key missing dependencies and installed all of those. So we were able to get that up to 86% of packages we have a successful build for, and 586,266 package versions successfully built, up to 83%. So now the reason for failure on round 2, your no release is right at the top there, so very, very, very few no release. The reason for that is, which we can also discount now, is because they have only uploaded wheels and no source distribution. So something like TensorFlow, for instance, they provide Linux, Mac, and Windows wheels. They upload those, and there's no source distribution available. You have to go to GitHub and find the project and look at all the instructions, and it's a complicated process to build it yourself. So there's things like that do exist, and again, we can discount those because there's nothing that we can actually build. And the numbers along here compared to the last one are a lot smaller. You can't really tell the scale, but we're down to a lot fewer failures than we were before. So now we've completed the whole build. We've got 100% coverage of we've attempted. We can scale it back down, and all we need to do is just keep up releases. So returned most of the Pi's back to Mythic, and carried on just sitting there building anything new that comes out. However, we did this on Raspberry and Jessie, which is now the old stable. So we recently released Raspberry and Stretch. So we've gone from Python 3.4 being the default to 3.5, and we also want to be able to support Python 3.6. So pure Python packages, so anything that's just written pure Python, when you build a wheel for that, it will work in any Python 3, any version of Python 3. But if it's a compile package, it's built against a particular ABI. So if you built it in 3.4, it's built for Python 3.4. and you have to rebuild it for 3.5, 3.6. So the build procedure now, so this is another thing we've sort of had to add in, is so keep the package list and version list up to date, so we were doing that before. We form a build queue for any unattempted package versions, so if something new gets released, we pick it up, and that gets appended to the build queue. We attempt to build everything in that queue. After something has been built, if it gets tagged with something other than any for the architecture, so if it's Linux ARMv7L, then we create a symlink from that file to, from the same file request but with Linux ARMv6L to the same, and deliver the same file. So we've built it on a Pi3, but we give you one we call ARMv6 for a Raspberry Pi 1 or 0 user. And if a wheel is tagged with an ABI other than none, trigger it to be rebuilt for other ABIs. So if you build NumPy, for instance, and it has an ABI tag of CPython 3.4, then that needs to be triggered to be rebuilt by a new builder that has Python 3.5. So we introduced stretch builders this week, and they will pick up anything in the queue that's tagged for this needs building for 3.5. That will be built for 3.5 and added to the web server. And so the same principle applies for Python 3.6, and we don't currently support any Python 2, but we will probably add a Python 2 builder at some point and probably have to do an entire build for all of those. So apart from those that are built as universal wheels, Python 2 specific wheels will be available as well. But we just really need to support Python 3.5 because that's the new stable. And so how do you get this? How do you use it? Or how do users use it? If you're on Raspberry and Jessie still, and you're not going to upgrade, you'll have to manually, actually have to upgrade pip to the latest version of pip and put something in a pip config file, which will tell it to use this server. But if you're on Raspberry and Stretch, the new stable, this is pip in that is now pre-configured to use piwheels as an additional index to the Python package index. So you can just do an upgrade, and you'll bring in the latest version of the pip package, which has that config preset. Or you can have a look on the website on how to manually do that as well. So the website of the project is www.piwheels.hostedpi.com, because that's running on the Raspberry Pi, the master Raspberry Pi in the Pi cloud. And that's the homepage. And the whole project is on my GitHub at /bennuttall/piwheels. Just to finish up, and we do actually have time for questions because I've been speaking incredibly fast, trying to get through these slides. My poster is downstairs in the poster session, so if you'd like to go and take a look, it looks like that. So thanks very much. I'll take some questions. Just time to one?
Yeah, probably just one or two.
Okay. Yeah.
Yeah, this is really great work, I gotta say. Is there a possibility of you getting these ARM packages back into PyPI itself? Is that important?
Okay, so I can't upload wheels to other people's packages. Package maintainers obviously have rights to upload additional files to theirs, so they could pick up a wheel that I built from piwheels and upload it themselves, and then it's on the main PyPI server. If it's a package that's specific to the Raspberry Pi and they built it for the Raspberry Pi and it's kind of predominantly for the Raspberry Pi, that's fine, except that it's kind of unnecessary because Raspberry Pi users should be getting this by default now. But if they're intending it to use on other ARM hardware users to be using it, I wouldn't be 100% certain that it will be compatible because of the ARMv6 lie that's told by the OS. So if they wanted to test it and they were confident in doing that, then that would be fine. The other problem is that if they upload one that's a true ARMv7 and they upload it, and then maybe it might not work on Raspberry Pi, so I'm not sure.
Thank you.
But it's an interesting one. Yeah.
Are there any bandwidth implications in downloading compiled rather than source? So if you're on a low bandwidth device, for example, might it be more desirable to download the source, or is that not the case?
I would have thought the other way around.
Okay.
I think.
Typically, binary packages are smaller than the source can be.
Okay, thank you.
Last one. Yeah.
You showed lots of statistics about PyPI and how much stuff builds successfully. Do you have the data available for that?
Yeah.
Is it something I could query myself?
Yeah.
Okay. What is the URL?
Oh, not publicly.
Okay.
I'll come and speak to me now.
Okay.
We do want to provide an API to this data, but we don't have it yet. But that's on the list.
Because it's actually something that's kind of interesting generally for pip
Yeah.
to be able to access.
It might make a good blog post actually, kind of a big roundup of that.
Have you thought about putting, what are the features that you would put into pip on the basis of this?
Well, it was nice that so Donald added support for ARM wheels in the new warehouse project, and that is now the new default backend to the old PyPI. So we're moving to warehouse sometime in the future.
Real soon now, I think.
But as I say, the back end for that is actually live now on legacy.pypi or whatever it is. So that was it really. That was good that they added that.
Thank you, Ben.